All right, ladies and gentlemen, welcome to today's showing of Holiday Lights. My name is Justin. Are you guys ready for some explosions today? Excellent, excellent. We want to first thank our sponsor, Chemical Abstract Service, for their support of our guided stage. Now, as you can probably guess, this show is going to be pretty loud and chaotic. We are going to be blowing stuff up here during our show. And I'm going to warn you, when we get to our louder experiments, what I would do is say, everyone, please cover your ears. And of course, that means everyone will need to cover their ears. So let's give it a practice. Everyone, please cover your ears. Excellent. Also, if anyone has an emergency, and if you need to leave during our show, you can exit through these doors on your left. Just try to do so in between experiments, okay? So today's theme is we're going to talk a lot about light, and we're also going to talk about a lot of cool stuff, okay? So first, let's do an experiment involving light. Before we put on our glasses, I'm going to show to you a burning candle. Now, there was this scientist back in the mid-1800s named Michael Faraday, lived in England. Big famous scientist. He used to give these long lectures about various subjects in science. And one thing he talked about was something called, or he talked about burning candle. Now, his lecture about burning candle lasted 6 days long. So who would like for me to recite his entire lecture? Anybody? Yeah. No, only like 2 or 3 of you. Okay, well, I won't go into that much detail, but one cool thing he talked about was a thing known as incandescence. Please put on your glasses for me. So in the center of the candle, what color flame do you see? Kind of a whitish yellow color, right? But what do you see surrounding that whitish yellowish flame? Rainbows, right? And what color do you see closest to the rainbow, or closest to the flame? Okay, so blue and purple, right? What color do you see further away? Red, yeah. So it turns out that this candle is very, very hot. So there's your science lesson today. Candles are hot. And candles gets its light from heat, right? So when light is produced by heat, we get this thing known as incandescence. And when we look at that light through those glasses, we were able to see all those colors come together to make that one color light. But enough with the science of a burning candle. While we blow some stuff up, shall we? All right, here we go. So, inside this Courier-Nice popcorn tin, which once contained an entire lifetime supply of caramel popcorn, I have 3 candles. And I have a powder. That powder is known as lycopodium. And it reminds me of a grain powder. You kind of see it here. And I want you guys to see what happens when the lycopodium hits a flame, all right? So we're going to use this lighter. Watch what happens. We're going to do this in 3, 2, 1. Whoa! You want to see that again? Yeah! All right, we're going to do it a little again. We're going to do it again. There we go. Here we go. 3, 2, 1. Whoa! Oh, yeah, pretty cool stuff. When the lycopodium hits a flame, it changes from a powder into a gas, and that gas burns up. And of course, when we change something into a gas, that gas grows and takes up more space, which is going to be perfect for our popcorn tin explosion. So what I'm going to do, I'm going to light up our 3 candles, one by one here. And then to get that powder to hit the flame, I'm going to use a bicycle pump. And I'll blow around that powder. All right, looks like our candles are burning. We're going to turn down the lights in a second. Now, this won't be a terribly loud noise, so you know, you're not sensitive to loud noises. You can leave your ears open, but if you're sensitive to loud noises, feel free to cover your ears. All right, here we go. We're going to cover this up, and we're going to do a countdown from 5. Okay, so here we go, everybody, from 5. 5, 4, 3, 2, 1. All right, well, let's see what happened. Candles may have went out. All right. So we're going to try that one more time. I think what we'll do this time, we're going to add a little more power. Because that'll be the answer to it all there. All right. Excellent. More powder. She gives us more power. All right. Very good. Light it one more time. Oh yeah, that's a lot of power. This has to work this time. All right, here we go. Try that one more time. All right, here we go. From 5, 4, 3, 2, 1. There we go, all right. Okay, a few of us, right? A few of us are old-fashioned like our light from candles. How many of us use something else? What is that something else? Electricity, absolutely right. Now, some of you may have heard of this guy before. His name is Nikola Tesla, a famous scientist, lived in Russia in the late 1800s. He developed a really cool way of making electricity. It is known as a Tesla coil, and I want to show you how cool this Tesla coil is, all right? So what we'll do, let's go ahead and turn this on for a second. Do you guys see these sparks here, right? Yeah. So, turns out the Tesla coil produces energy that we can see, light, okay? But also, the Tesla coil gives us energy that we cannot see. And to be able to help me show that, I need the help of a volunteer. Who would like to help me with this? Let's see. Back in the back. How about you in a hat? Come on down. All right, what's your name? Jude. This is my buddy Jude. Everyone say hi to Jude. Hi. Jude, say hi to the crowd. Okay. Jude, come on up here to the stage. I want you to stand right here for me. Okay, so here's what Jude is going to do. Jude is going to hold this tube. This tube is filled with a gas known as neon. How many of us have heard of neon before? All right, very good. What happens when you give neon some energy? It glows, yes. So I want you to hold the tube by the middle there. Very good. And Jude, what we're going to do, let's go ahead and turn down the lights here. We're going to turn down the lights up above. There we go. And I'm going to turn on our Tesla coil. Bring it a little closer, Jude. All right, very good. Yeah, pretty cool. Yeah, well, your hand's giving a little bit of resistance there. That's why it's not as bright on that other side. All right, now go ahead and put on those glasses there. What do you see now? Do you see a rainbow? Do you see like all the colors, or are there some gaps? There are big gaps now. Turns out that this light is not produced by heat, but by gas becoming excited, okay? When that gas becomes excited, it glows. But it turns out not all the colors in the rainbow are needed to make the color light that we see from our neon tube. Pretty cool stuff there. Now, hang out here for a second here, Jude. I'm gonna turn that Tesla coil down for a second. Now, I know most of us don't get our light from neon tubes at home, but a lot of us use fluorescent light. So I have actually a fluorescent light behind this fragile box here. What are you guys laughing about? It's my lamp here. Won it as a major award. All right. Yeah, it says fragile on there. Yeah, there you go. All right, so Jude, I want you to hold that tube there. Be very careful. There we go. We're going to turn on the Tesla coil once again. Turn down these lights. Here we go. Wow. All right. Now, take note here. Our light is not plugged in, okay? But, again, we have electricity being sent through the air, invisible energy being produced by our Tesla coil, and our fluorescent light is picking that up. And again, you're not seeing a full rainbow with our fluorescent light, only certain colors of the rainbow. Pretty cool stuff. All right, and the fluorescent light, by the way, is made very similarly to the light that we get from our neon tube, not like a candle. All right, I'm going to turn that off. I will take the tube back. Let's give Jude a nice big round of applause. Thanks for helping. Excellent. Yes, you can go back to your seat. Thanks for your help, bud. All right. Now, I think this is such a beautiful light. I want to keep it on throughout the show, so we'll keep that on here throughout the rest of our show. All right. Now we're going to move on to our next experiment. Okay? We're going to do an experiment where we're actually going to generate some electricity for our experiment. And you guys remember that scientist earlier in the day we talked about, Michael Faraday, who used to give those big, long, boring lectures about candles? Turns out he was good for something, okay? And to help me show this, I need the help of a very strong volunteer. Who would like to help? Someone who is strong. Who's feeling strong today? I'm looking for somebody who's strong. How about, wait, you're right here. You're in white, yep. Yes, in white. You don't want to go? Oh yeah, I think you do. Yeah, there you go. Go on down. He looks so surprised I picked him. All right, come on down, buddy. All right. Now, I'm going to ask you what your name is. And no, that's not your name. I'm going to say hi. You're going to say, hi, my name is Rudy. Can you do that? Okay, turn around. Hi, what is your name?
Hi, my name is
Rudy, I think I recognize you. You drive around a guy who wears a big red suit and drives around a sleigh one night a year. Is that right? Yeah, I thought that was you. Rudy, I want you to stay right here because Rudy uses this really cool thing here to keep him in shape throughout the year. It is known as a reindeer training apparatus. See that? And Rudy has a very sophisticated helmet with a light bulb and a speaker attached. Rudy, hop up here for me. Attached to Rudy's sophisticated helmet is a wire that leads to a Faraday generator. That Faraday generator has magnets in it, and when Rudy goes for a spin on the generator here, or on the apparatus, it's going to move those magnets. When we move magnets, we can make electricity. Very good. Now, Rudy, you know how to use this, right? All right. So, helmet's a little big on you. It'll be okay. All right. Go ahead and put your legs on the pedals and give it a spin. Here we go. Very good. Excellent. You hear that speaker? Rudy's pedaling through the fog. All right. Can you crank it up just a little bit more, Rudy? There you go. A little bit more. A little bit more. Go, Rudy. Go. Go, Rudy. Go. Go, Rudy. Go. And oh! Rudy, take a look here, buddy. Do you make all this electricity? Do you make all this? You think so? Let's take a closer look. No, the generator is only connected to Rudy's very sophisticated helmet. But now you know how we're making our electricity here at COSI. Hundreds of people on bicycles downstairs right now all think they are at the gym. All right, Rudy. Rudy, your work is done. Thank you for coming down. You can go back to seat. Let's give Rudy a big round of applause. Thanks for helping. All right, now, folks, I invite you to go ahead and put those glasses back on for me. All right. I hear a few woes. What do you guys see? Oh, yeah, lots of rainbows, right? Now, remember earlier how we had that candle, right? And we saw, what, maybe about 8 different rainbows with just that one candle light? Turns out inside of our lights here, we have the same kind of light. We have an incandescent light from a wire getting very, very hot. And now, instead of having just one of those kind of incandescent lights, we now have 12,000 incandescent lights. If each one gives off 8 rainbows, that gives us 100,000 tiny little rainbows, all coming together to make this room turn black. Pretty cool stuff. Now, these glasses, they are yours to keep. Take them home with you, look at all the lights, you can watch your TV with them. The only thing I recommend, don't look at the sun and don't drive with them, okay? Very good. We're going to go ahead and turn these lights down because it is time to do some really cool stuff, okay? This really cool stuff that I'm about to show you comes from the #1 ingredient of our air, okay? It starts with an N, rhymes with nitrogen. What do you suppose it's called? Nitrogen. Nitrogen, yes. And what I have is a form of nitrogen in this air that is so cold, you guys say, how cold is it? I'm so glad you asked. It's so cold, it's no longer a gas like we breathe. Turns out we have a liquid. When scientists found this stuff, they were pretty amazed. They had to give it a big fancy scientific name. So what do you think with those big fancy scientific names scientists like to give? What do you think they call our liquid form of nitrogen? Liquid nitrogen, yes. Those scientists are clever. Now, here I have an aluminum pole. And what I'm going to do is stick this aluminum pole into the liquid nitrogen. And you guys see this cloud coming up. Turns out the pole is causing that liquid nitrogen to boil back into a gas very, very quickly. Okay? Now eventually that cloud is going to begin to dissipate like it is right now. So that means what we have up there again. So eventually that cloud will completely dissipate and we're going to have a very cold pole. All right. Very, very good. We'll come back to that in a second. Now, over here on your right, I have this thing known as an Erlenmeyer flask, which is my all-time most favorite name in science, okay? And what I'm going to do, we're going to pour a lot of this liquid nitrogen. All right? Try not to spill any. Let's see. Don't tell anyone I'm spilling all this liquid nitrogen. All right. Now, this tube here is made out of copper. Copper, very good conductor of heat. I stick it into liquid nitrogen, going to cause the liquid nitrogen to boil even faster. That liquid nitrogen is going to shoot up through this tube and create a really cool effect known as a genie in the bottle. Are you guys ready for a genie in the bottle? Okay, here we go. 3, 2, 1! Oh, that is so cool. Pretty neat stuff. And what is shooting out is a cloud. We have very cold nitrogen gas changing the water vapor in our air into a cloud. Pretty cool stuff. All right, now that bowl's really cold. All right, now we're going to use this liquid nitrogen as explosion fuel for our giant snowball. All right? Because this liquid changes into a gas very quickly, when I pour it into our snowball, it is going to build up pressure. And after a while, that pressure becomes so great, the bottle will not be able to handle it. I'm sorry, the snowball will not be able to handle it. And the weakest part of the snowball will explode. All right, very good. Who would like to hold on to the snowball? That was a joke. Give me about 30 seconds, you'll see why. Here's what I'm going to do. I'm going to run up the stairs, throw the ball in that barrel. And I don't know about you guys, but I'm going to run like heck. But don't worry, Karen, I've done this experiment, once or twice before, and most of the time it works out okay. Is that right? Yeah, most of the time. Okay. So, as I mentioned, it's going to be a very loud noise. It's going to be as loud as any TSO or Mannheim Steamroller concert you've ever been to. So, before I turn down the lights and drop the ball in this barrel, I have to ask, is everyone ready? Wait a second. That was not everyone. Is everyone ready? All right, very good. Now this is going to be incredibly loud, maybe the loudest noise you've ever heard indoors before. So, everyone, please cover your ears. Here we go, ears covered. Make sure his ears are covered, because sometimes this actually works. And when it does work, it can be very loud. Woo! All right. Very good. Was that as loud as I told you to be? No. All right, well, we're going to move on to our next experiment. Now, this time of year, of course, we get to watch a lot of those really cool movies on television. And there's one famous movie where a young man is dared to do something. What does he dare to do? Stick his tongue on a pole. Now, was that just any old pole? No, that pole was very, very cold, okay? So, I know some of you out there doubt that that's actually possible. To prove it, I need a volunteer. We have predetermined this volunteer. His name is Slushy Jr. Some of you might have met Slushy Jr.'s dad, Slushy Sr. And as I can tell, Slushy Jr. is missing a few balls compared to his dad. Okay? Now, Slushy Jr. has agreed to do this under 2 conditions. One is that we give him a drink of water. 2 is that I dare him. Okay? So we're going to do that. Let's first give Slushy Jr. a little drink of water before he attempts this highly risky experiment. Excellent. So Slushy Jr. has his drink of water. Now, all I have to do is dare him. So Slushy Jr., I dare you to stick your tongue on that pole. No way. Okay. I double dare you to stick your tongue on the pole. No way. Huh. I don't know what to do. I thought Slushy Jr. would agree. What? Triple dog dare him, skip every rule of the playground and go straight to the triple dog dare? Yeah. All right, are you guys willing to do that? All right, all at once. I triple dog dare you. All right, I'll do it. Oh, wait. Hey, I'm stuck. Come back. The bell rang. right, and I guess we'll call for an ambulance for the fire truck after our final experiment. How's that sound? All right, Sasha Jr. can hang out for a while. Now has come time for our grand finale. And for our grand finale, we were gonna have fire, and we're gonna have explosions. How's that sound? Yeah! All right. I have a feeling you guys would be okay with that. Now, of course, to have fire, you need a few things. You first need some fuel. You need some heat. You need some oxygen. Where can we get oxygen from? We can get it from the air, absolutely. For our heat, what I have done is I've attached a sparkler to this stick, okay? That sparkler will provide all the heat we need. And for our fuel, what we have are 2 balloons. Inside the 2 balloons is a gas that's lighter than air. It starts with an H. What do you suppose it's called? Helium is an excellent guess, but helium doesn't burn very well. It just makes your voice talk funny. Hydrogen, yes. Now, there are 2 ingredients we need for fire, right? Other than heat, we need fuel and the oxygen. So what's going to happen is our fuel, called hydrogen, and the oxygen from our air will mix together, and the brand new stuff that we're going to get from that is called H2O, everyone. What is that? Water, yes. And because of that, back here, I have somewhere back here. Oh, maybe I don't. Uh-oh. This is not going to be good. Oh, it's down here. Okay. I'm going to put on this umbrella hat. All right, very good. You guys have one as well. They're all under your seats. Down there? Are they down there? Someone's supposed to put them out. Oh, no one put them out before the show. Oh, well, I do have a plan B. Can I get your help? Come here for me. What's your name? Zach. Now, Zach has graciously agreed to help me keep all of you dry. Here is how Zach is going to do that. Zach is going to hold up this umbrella. Okay? So, Zach, take this umbrella, go back to your seat, hold that up for everyone, and if anyone gets wet between now and the end of the show, blame Zach, not me. One more thing. Now, of course, fire explosion kind of reminds me of a firework, right? And are all fireworks the same color? No. Right, you get different colors from fireworks, otherwise you'd have a very boring fireworks show. So what we've done to our 2 balloons, we've added some chemicals to give us some different colors. On your left here, we have a chemical called strontium, kind of a salt-like substance. What are you guys pointing at? Am I just that funny? Strontium that funny? Oh, yay, I don't have to call for a fire truck. Yeah, all right, very good. When that strontium burns, it gives off a red flame. Green balloon has a chemical in it called barium. When that burns, it gives off a green flame. The barium is kind of a powder-like substance, okay? So, we're going to turn on the lights in just a moment. Now remember, folks, we're not just going to have one big loud explosion, but we're going to have 2 big loud explosions, all right? So, before I turn on the lights, I have to ask, is everyone ready? All right, that sounds like everyone. This is going to be very loud, so everyone, please cover your ears. Here we go, everyone. All right, that one doesn't work. We'll try this one. Ears covered. All right, we're gonna do green first. Green, in 3, 2, 1. Now red, 3, 4, 2, 1. All right. Zach, any water in your umbrella? No. Did anyone get wet? What happened to all that water we made? It boiled away, evaporated, yes. How many of us felt the heat from the fireworks? Yeah, so did I. And so did that water. That water almost instantly boiled away into water vapor. But some of that water managed to make its way into